Welcome class. In this video I want to discuss function compositions and their domains. So for example, if we have f of x equals 2 over x and g of x equals x over x minus 1, and I want to find f circle g of x. So this is the composition of f and g. This means that I plug g inside of f. So that's going to be 2 over, so here's f. I'm going to plug all of g inside of f. So that's going to be x over x minus 1. And then simplify this. This is 2 times x minus 1 over x, which is 2x minus 2 over x. Okay, so now this is my function composition, and I want to find its domain. So the domain of a function composition, we want to look at the domain of g, the domain of f of g, and see where they overlap each other. So with g, x can't be 1. So with g, x cannot be 1. And with our function composition, x cannot be 0. So my domain here is going to be from negative infinity to 0, union that with from 0 to 1, union that with 1 to infinity. Okay, so my domain is where g of x and f of g of x overlap. Let's look at another one. Let me change colors so you can easily tell it's a different problem. Let's see if I have, let's do g of f of x. Yeah, so let's do g of f of x. So same functions, but we're going to do it in the opposite order. So that will be, this time I'm plugging f of x into g of x. So it's going to be 2 over x over 2 over x minus 1. And we don't want to leave this nasty compound fraction here, so let's simplify things a little bit. On the bottom, I can make this with common denominators pretty easily by changing this 1 to an x over x. So that's going to be 2 over x over 2 minus x over x. And then we can do the same trick that we did up here by changing this big division bar to multiplication and flipping my bottom, my denominator, to be its reciprocal. So that's going to be x over 2 minus x. And then my x's here diagonally can cancel, so I'm left with 2 over 2 minus x. Alright, so now let's look at my domain. So the domain of my function g of f of x, the inside function here is f, and the domain of f, if we look up here, f cannot be 0. So it can be everything except 0. And if we look at my final composition over here, notice that x can't be 2. X cannot be 2, because if we do, then we'll be dividing by 0. So my domain is going to be where these overlap, so it's all real numbers except for 0 and 2. So my domain is going to be from negative infinity to 0. And then union that with 0 to 2, and then union that with 2 to infinity. Okay. We could also do like f composed with itself. So let's look at that. Let me change colors so you can see that we have a different problem. Like you can have f composed with f, or f composed with g. Or g composed with g, like any combination works. So that's going to be 2 over x, because notice I plug f into itself, so 2 over x gets plugged in for x in 2 over x. And then we can flip this, so that's 2 times x over 2. The 2's will cancel, so we're just left with x. So now if I want to find my domain, so with f, it can't be 0. With f composed with f, it can be anything, because you can plug anything into x and it doesn't change the problem. So where all real numbers here overlaps with all real numbers except 0, that's going to be all real numbers except 0. So that's from negative infinity to 0, and then union that with 0 to infinity. Okay, so this is my domains and function compositions, and notice that all 3 of these domains are different, so don't expect them to be the same just because it's the same 2 functions up here. Okay, alright, and that's all for this video.